Alright, so let's simplify some radicals. We've got some square roots of numbers here. They're not as simple as they could be, and we don't want to turn them into decimals either. Let's see if we can simplify them. And one method is to keep an eye out for perfect squares. Um, Here's a list of some perfect squares. 4 is a perfect square because it is the product of an integer and itself. So 2 times 2 is 4, 3 times 3 is 9, 16, 25, 36. These are all perfect squares. You can square root them and get a nice, even, um, clean integer. Um, if you can think of these radicals as the product of some radical and the square root of a perfect square, you could just square root that perfect square and get a nice integer out of it, and then therefore simplify this. So, for example, here's what we're talking about. So, 128 is 64 times 2. So I could say that this radical expression is equivalent to the square root of 64 times the square root of 2. The square root of 64 is just 8. 8 times 8 is 64. So this is equal to 8 times the square root of 2. And then that's the simplest form. Now, if it's difficult to see where a perfect square might be hiding there, that's okay. I mean, you don't have to find a perfect square. You could just factor um, this 128. Just do like a factor tree and say like, um, looks like maybe 4 goes into 128. So maybe like if we do 128 divided by 4, yeah. So 32 times 4 is 128. We could break this down like 16 times 2, and 4 is 2 times 2, and or in fact we could stop there instead of even going there. Then we could say, well, this is the product of, we could say is this is equivalent to the square root of 16 times the square root of 2 times the square root of 4. And the square root of 16 is 4. The square root of 4 is 2. 4 times 2 is 8. So, and then this is just what it is, right? So that's fine. This whole perfect squares business is just a shortcut. If instead of factoring it very far with the factor tree, instead of factoring it all the way down to its prime factors, if you can look for perfect squares, that could save you some time. So, for example, I saw that 128 is just 64 times 2. So this radical expression is equivalent to the square root of 64 times the square root of 2. 64 is a perfect square. Boom, boom, done. Right? Um, so yeah, so it's just a shortcut. So if it's not easy to see, don't worry about it. Just factor until you can see some things that you could square root and get out of the radical. So let's practice. So 150 is what? Is 6 times 25. Yeah, because 4 times 25 is 100, and we've got two more 25s. 2 times 25 is 50. So we could write this as the square root of 6 times the square root of 25, because 6 times 25 is 150. Well, 25 is a perfect square. Square root of 25 is 5. 5 times the square root of 6. Can't really do anything further with 6. It's the product of 2 and 3, but neither one of those is a perfect square, so it's not going to help us simplify this. So that's as simple as we can get. 243 is I don't know. Let's see. No perfect squares are jumping out at me, so let's just start factoring this thing. 243, 2 plus 4 is 6, plus 3 is 9. So this thing looks divisible by 3, so let's just do 243 divided by 3. Oh, okay, that was it. Yeah, so this is equivalent to 3 times 81. So 81 is a perfect square. That's 9 times 9. So this expression would be equivalent to 9 times the square root of 3. So the square root of 81 is 9, comes outside the radical, and then this is left. Alright, so that's the basic idea. Try these ones. If it's hard to see perfect squares, just start factoring until it becomes clear, or if you need to, factor it all the way down to the prime factors. And then it should be clear what you can square root and get out of the radical. Alright, good luck.